Good morning. This is Sudha from the Department of Mathematics. I am choosing the topic cyclic groups. The definition of cyclic groups says that let G be any group, A is an element in G. Define G is equal to set of all A power n such that n is an element in G. Then we say that A is called a cyclic group generated by A and it is denoted by G is equal to A. Then A is called a generator of G. Example, the multiplicative group G is equal to set of all plus or minus 1 and then plus or minus I is a cyclic group. Then the generators are I and minus I. The following theorem says that every cyclic group is an abelian group. Proof, given that G be a cyclic group, so that by the definition we write that G is equal to set of all A power n such that n is an element in Z and then A is called a generator of G. If we consider xy is an element in G, x is equal to A power m, y is equal to A power n. M comma n is an element in Z. So xy is equal to A power m into A power n. Here the base is same. So we can add the power. A power m plus n. We rewrite the m plus n as n plus m. That is equal to A power n into A power m. That is equal to yx. Therefore, xy is equal to yx. The commutative law is true in this group G. Therefore, G is an abelian group. We have proved that every cyclic group is an abelian group. Next definition, division algorithm. If A, B are integers and B is not equal to 0, then there exists positive integer q comma r such that A is equal to bq plus r where 0 less than or equal to r less than q. Example, 10 is equal to 2 into 4 plus 2. Theorem, let G be a cyclic group and H be a subgroup of G. Then prove that H is a cyclic subgroup of G, or also we call as prove that every subgroup of cyclic group is cyclic. If they given, let G be a cyclic group, so generated by an element A, let H be a subgroup of G. Therefore, if H is equal to E, if H is equal to E, then H is a cyclic group and generated by E, which proved the theorem. Suppose if H is not equal to E, also H is a subset of G, let m be the smallest positive integer such that A power m is an element in H. We need to prove that H is a cyclic subgroup generated by A power m. Let A power s is an element in H. By applying division algorithm, if we consider s and q are integers and q not equal to 0, then there exists positive integer m comma r such that s is equal to qm plus r, where r less than or equal to 0 less than m. Therefore, s minus qm is equal to r. We consider a power s comma a power m is an element in H. For a power s into a power m the whole power q is an element in H. Since a power s comma a power mq is also an element in H. For a power s, a power mq, the whole inverse is also an element in H. Therefore, a power s comma a power minus mq is an element in H. Therefore, its product a power s into a power m minus mq is an element in H. Therefore, a power s minus mq is an element in H. Therefore, s minus mq is equal to r. Substitute here, a power r is an element in H. Consider m as the smallest positive integer such that a power m is an element in H, that 0 less than or equal to r less than m. Hence, r is equal to 0. Substitute s minus qm is equal to r. Therefore, s minus qm is equal to 0. Therefore, s is equal to qm. Hence, s is equal to qm. Therefore, a power s is equal to a power qm. Therefore, a power s is equal to a power m the whole power q, for q is an element in Z. That is, every element of H is a power of a power m. Hence, we proved that H is a cyclic subgroup generated by a power m. That is, H is equal to a power m. Hence, every subgroup of a cyclic group is cyclic. Thank you.